Hi, when you are testing high-speed Ethernet, it is important that you start by considering the Layer 1 performance before moving on to the packet testing at Layer 2. In this video I am going to introduce some of the many Layer 1 features available with the Freya 800G test modules that enable you to use the same test equipment for both L1 and L2. The setup I'll be using is shown here. It consists of two Freya modules and one of our BAE 2400 chassis and connected with a 2-meter long DAC cable. The chassis is controlled from the Xena Manager software. Of course, one of the Freya modules might be your device under test, or maybe the cable is what you are testing. If we look in the Xena Manager, you can see the chassis with the two Freya modules. And if we click on Resource Properties and select one of the modules, we can see the details about the module here. And also see that the module is configured to a single 800G port. We could also have chosen 2x400G, 4x200G, or 8x100G. Let's first have a look at the transceiver information. We find this by selecting one of the ports and choosing Transceiver Features and Basic Info. Here you can see all the basic information available about the transceiver, like vendor, and for instance the cable length down here. If you click the CMIS Explorer tab, you can see all the content of all the registers through the CMIS interface. And with the R/W tab you can even edit some of the CMIS registers. The Layer 1 of the OSI stack consists of a number of subfunctions as shown here. At Teledyne LaCroix, we have implemented our own PHY, called Xena PHY, which enables us to offer a large palette of Layer 1 test features. With the Xena Manager you can investigate, configure and test all these different subfunctions. We will start from the bottom with the physical medium. Here, you have the option to view the signal integrity of the 4 PAM levels as shown here. These lines represent sampled values of all the received symbols sampled. The thinner the lines, the better the signal quality. If you select the RX tab, you can see all the details of the various RX equalizers. As you can see, there are both CTLE, DFE, and several FFE, so it is a bit complex. With the TX tab you can control the settings of the transmit equalizer. For 112G SerDes this is a 5-tap equalizer. The current setting is optimized for the 2-meter cable attached. But you can change the settings of all the taps in case you want to test how sensitive your device is to NN optimal equalizer setting. We have enabled you to configure the tap setting the way you like the best, either as the step sizes or as MV for the main tap and dB, IEEE relative values, or the step. Here, I'm just changing the main tap from 86 to 85 and back to 86 again. Auto negotiation and link training are important protocols if you are working with electrical cables. If we click the ANLT tab, you can configure how you want to run auto negotiation and link training. Up here you can enable auto negotiation alone, link training alone, or auto negotiation followed by link training. Below you see the technology advertised by our port. At the bottom you can also see the results of the latest auto negotiation and link training process. At the PMA sublayer you have the option to test using PRBS sequences and insert bit errors. If we select the PRBS tab we can choose between different patterns to be sent in the drop-down box here, and we can send out a PRBS sequence on all lanes by clicking here. And then, if we go to the receiving port, we can see the number of bits received, the number of errors and the error rate for each SerDes lane. In the PMA tab you configure whether each lane should use pre-coding and/or gray coding. The Xena Manager also lets you check the PCS sublayer and the performance of the FEC. Here, we have added a packet stream of data from the remote transmitter and are looking at the received performance. If we scroll to the bottom we get this nice graph of the error distribution and estimated pre- and post-FEC bit error rate. When in the Layer 1 mode, it is possible to test the performance of UFEC implementation by choosing the FEC Error Injection tab here. This allows you to configure the amount of code words with errors down here, and test the configuration by pressing Start. Another nice feature is that you can deliberately swap PCS lanes. Simply click on the lane number and type in a new number. As you can see, the previous lane number 1 now becomes lane 0. To reset the PCS lane, just scroll down and click on Reset TX Lane Swapping. So I hope this small overview of the Layer 1 features in Freya and our Xena Manager has interested you in trying out our demo setup and test it for yourself. Go to our website xenanetworks.com and click on here, on Try Live, Demo Now, or contact your local sales rep. You can find your local contact by clicking this button. Thank you for watching.